So this will be our first video about conic sections. I'll probably be moving around the board quite a bit, trying to make sure my fat head isn't blocking so much of the math, because these are a little bit algebra intensive. And a conic section is literally just a section of a cone. So here we have a poorly drawn cone. Depending on how you cut it will determine the shape that you get. So a circle, you have a plane that cuts directly across. That cross section will be a poorly drawn circle. If you cut it at a diagonal, it's stretched out, giving you an ellipse. Right? And there are a couple other shapes we'll discuss in future videos. The most important thing about conic sections is you must know the standard form of the equation. If you know the standard form, you know everything you need to know. Now, for our lovely Algebra 2 book, which we are all so familiar with, they never give you standard form. And their examples on how to get it are fairly lackluster. So if you don't have a strong background in college algebra, this section is usually pretty tough. So let's talk about it. For circles, you only have one standard form. It's your x term squared plus your y term squared equal your radius squared. If your center of the circle is at 0, 0, it's at the origin, then it's just x squared plus y squared equals r squared. Nice and easy. Now for conic sections, and this is true in all versions of algebra I've ever taken, h and k, h, comma, k is always your center. Right? So anytime you see h and k in a equation in this book or any other math book, it's the center of your shape, right? Whatever shape it is. We may not know what that shape is by looking at it, but h and k always stands for center. So let's examine this a little bit. I've got an example here. Right? It's x minus 4 squared plus y minus 5 squared equals 1. Now, since they're both squared and it's plus, we can tell by looking at it this is a circle right away. And our center, since it's minus 4 and minus 5, I can tell that our h and k is 4 and 5. They will always be opposite sign of your standard form. So if it's negative inside, it'll be positive to graph. And the square root of 1 is 1, so that's 1 squared, telling me you have a radius of 1. That's nice and easy. So we can graph this pretty straightforwardly just by counting. Right, so I'm going to draw a Cartesian plane. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right? So when I graph my center, it's at 4 and 5. It's right there. Right. This is not to scale. I'm famous for my bad drawings, as many of you know. Okay. And we just count our radius, which in this case is 1, in all 4 cardinal directions. So we go up 1, down 1, right 1, left 1, and then we draw a poorly drawn circle. That actually looks pretty good. All right, I'm pretty happy with that. So as you can see, once you have standard form, you're golden. So you can graph that, you can manipulate it, you can stretch it, you can translate it around, do whatever you want. If it's not in standard form, what you end up with is a monstrosity like this one up here. Okay. Now, when I look at that, I can still tell it's a circle, right? Because they're both squared, neither one of them has coefficients, and they're plus. It has to be a circle. And that's really all I've got. So we're going to have to put this one in standard form before we can do anything with it. And in order to do this, since these are both squared and we have no common factors, is we get to do CTS. Right, which remember from a previous video is complete the square. And I told you in that video that you use complete the square to change the form of an equation, and now we're actually going to do it. So step 1 for completing the square is to move our constant term. We only have one constant, it's 20. So I'm going to subtract that to the other side. Right, now key is I want all my common variables, my like variables together. So I'm going to rearrange it in this step. So I have a pair of x's. I'm going to rewrite those in parentheses. So I've got x squared and 10x, and I'm going to leave a little space. And for my other one, I've got y squared and negative 4y. I'm going to leave a little space. And my negative 20 to be off by its lonely self over here. Now I have to complete the square on both of these. Right? And here's where that rewriting comes in handy. So I'm going to rewrite my 10 so that I can divide it, give me 5, and the square, give me 25. And I have to add up to both sides of the equation. One goes in with the x, and one goes on the opposite side of the equal sign with the negative 20. Now I'm going to do this one. So I rewrite by 4, divide it by 2, and I square that, giving me 4 again, which is convenient. This one goes in with a y, and on the opposite side of the equal sign. Now both of these automatically factor. We don't have to do any math on that. So I'm going to draw my parentheses squared. I bring down my first term. I bring down my first sign and the square root of my last number, which is 5. My other set of parentheses. I bring down my first term, my first sign, and the square root, which is 2. And over here, I'm just going to simplify. I'm going to collect all my like terms. Negative 20 plus 25 is 5. 5 plus 4 is 9. And last step to get it into standard form is I need my square root. A lot of students will try to leave it like this. It's not that it's necessarily inaccurate, but it is not standard form. If you tried to graph it like this and you counted up to 9, that would give you an incorrect graph. So that's x plus 5 squared, y minus 2 squared equals 3 squared. So now I can tell by looking at this that my HUK, my center, is at negative 5 and positive 2 with a radius of 3. So if you graph this, 3, 4, 5. Okay, so my center is at negative 5, 2. So negative 5 and 2 is right there. And I just count 3 in all of my cardinal directions. So I go up 3, right 3, down 3, and left 2, 3, and draw hopefully a circle. That one's a little more of an egg, but I'll take it. Okay. And that's it. Once you get it to standard form, that's everything you need to know. You can tell your center, you can tell your radius, you can graph it, whatever you need. And that is it for circles, the easiest ones.